Okay, so sir, you can
Yeah.
start. Yeah.
Yes, that's what I was going to say. Very, very good evening to everybody. Welcome to you. There's another beautiful session. Today, we are going to explore the basics of electronics and electronics components, their fundamental structures, how series and parallel connections are work, and probably a basic introduction to Arduino and the codings. So as everybody are very familiar to the platform of Thinkercad, let's land up to the very similar page, the Thinkercad itself. Here today we'll be exploring a different section. You were very familiar with the 3D designing, as Saurav sir already taught you guys like how to make 3D designs and do stuffs and do creative innovations out of it. So today we'll be exploring a section called circuitry. So from the create section itself, you can land up to a page called circuit. Just click on it and it will load your system. Okay, so here we are. This is our base for circuitry. Now we'll be exploring different types of electronic circuits, electronic components, and we'll having a hands-on on everything. Like you can go parallel with me, or you can take down your notes and try it out. So every possible electronic circuits out of there can be either simulated or can be made out of it. So the basic purpose of Thinkercad platform or this simulation platform is we don't want to destroy our hardware at our single go. If we're unsure about our connection or we want to check the connection if it's working fine or not, we just make the connection over here, simulate it, and simulate it according to our need, pass all the test cases, then only we go on to the hardwares and make the connection properly so that we don't have a hardware damage, or else that will be like cost effective, or you can say the waste of energy or waste of time. Accordingly, let me guide through all the sections over here. First, we have this tool trip, which basically you can draw wires from here, and there is a simulation section in the top right corner, which actually makes you to start your simulation. And the next, the right corner, which is just below the simulation section, is the components. You can browse all the components, basic components, and if you're familiar with Arduino, you can get a lot of things about the Arduinos and all. So this platform is basically a very good, and this is open source, so you can log in and can enjoy your stuff, so you can enjoy your creativity at any point at any time of the day. So starting from it, we'll be doing a few more hands-on. So first of all, I'll be introducing you the component called register. Okay. So everybody will be familiar with this small device. This is our register. The purpose of a register is actually it protects us, or you can say it protects the electronic devices, or it opposes the flow of electrons. If there is excess flow of electrons, the registers can effectively protect it. Okay, so if you are very common to electronic circuits, you will be seeing that every LEDs are being countered by a register. That is because we need to protect the LED from bursting. That's why we use a register. If you use a register, you can change this resistance, or if you can value from this a little dialog box. It has a first of all you can go to kilo ohms, or you can go to ohms, micro ohms, any mega ohms or giga ohms, any particular values you wish to. So if you take this register, the purpose what I am telling, why we need a register. For example, this is a LED, right? This is a LED. LED has two terminals, like the cathode and the anode. The anode is always the positive one, and the cathode is always the negative one. Okay. Now let us take a battery. Let us take a 9-volt battery for our purpose. There is a 9-volt battery again. It has a positive terminal and it has a negative terminal along with it. So always remember, we'll connect the LED to a register. This is our register, and we should always connect a register to the positive side of the LED. Or you can say the anode. Okay, this is the anode, and this is the positive side of the LED. I'm connecting a register to the positive side of the LED, and let us make the connection complete. This is the positive end. The positive end should go to the positive side.
You have to write a program to accept two numbers and you have to find the HCF and
I would request everyone to go on mute. Okay, thank you. So that is it. This is the positive side of the register, which has been connected to the positive side of the LED. So this should be going to the positive side of the battery itself. Let us color code the wire with the color red. And from the negative terminal itself, let us take another wire and go to the cathode. Let us color code as black. So this completes my circuits, right? So this completes my circuit. And if I want to simulate it, I will simply go to the start simulation section. If I go to start simulation, you can see my LED is glowing. Okay. So this is a pretty simple circuit. You can see the LED is glowing. And now the big question takes part. Why do we need a register? If I remove the register, now this is my negative and this is my positive. Let us connect the positive terminal uh, to the battery itself. Okay, and let us color code it as red. So this also makes my circuit complete. But when I start simulation over here, my LED is bursting, which means I need some protective device or something which will resist the flow of excess electrons or the excess current. This is basically where we need a register. So without a register, we can damage our devices. For example, LEDs, for example, your buzzers, or any other like any other components that need a protection from excess flow of electrons, we can counter it by a register itself. Okay. Now let me introduce a very common component of electronics, or you can say when you make electrical circuits or electronic circuits, a very handy and useful component is called the breadboard. This is the breadboard. Okay, so you just what you have to do if you want to take a substance or you can take a component to your drawing screen, you just have to click on the substance and drag it like this. This will make your components appear in a circuitry window. So this is a breadboard. So breadboard actually makes our connection very easy. So what it is, like, you can say its importance, or you can say the advantages are some some uh, some circuits or the some in the points in the breadboard are always internally connected. For example, if I hover my mouse over these points, you can see there is a thin green line, which actually means all the points here are internally connected. That means if I get a similar supply from here, I'll get the same supply from this terminal also. That means from this terminal to this terminal, all my terminals are internally connected. And same goes for this also, this positive and the negative. This all terminals are internally connected. If you go and check, this all terminals are internally connected. Now, again, when I move on to the middle section, it also says they are connected in a vertical way, right? They are connected in a vertical way. All these are connected in a vertical way, and among them, they are in terms of electronics, you can say they are connected in series, and along with it, they are connected in parallel, right? And similar goes to the other side also. And you can see there is a break in connection over here. A thick gap is given. That means there is no connection from this board to this board. So we have a connection gap in between. So this actually explains our breadboard. So what can we do? We can make the same circuit over the breadboard. For that, let's take a LED over here and let's take a register like this. Okay, so I am connecting this end to this end. That means this whole line is my positive, or you can say this whole line is my anode. Okay, I will just connect this portion to the positive side of the terminal and this portion to the negative side of the terminal. Okay, do the same for it. Let us take a battery. Let us connect the positive side to the register and the negative side to the negative end of the LED, and color coded. So this actually completes my circuit. If we observe, we have gaps in between the LEDs and the connection, but that has been taken care by the breadboard itself, because every these terminals in the breadboards are internally connected. So if you're actually testing your connection, you can use your breadboard for that. Okay, so let us go for the result. If we go on start simulation, we can see it's automatic. The LED is glowing. Okay, so I says that my breadboard connection is okay and my other connections is okay. Right. So that was the beginning of it. Let us now explore this circuit with a very common example, or you can say with a very common component called switch. We have a option, or you can say we have a component called slide switch over here. Let us drag it to our breadboard. Okay, so it has a slide switch. One is terminal one, the other is common, and the next terminal is terminal two. Let us forget about terminal 2 for this time. We'll be working with terminal 1 and the common. So whenever you take a battery, always remember, we'll be connecting the positive terminal to the common of the slide switch. So this is my common of the slide switch, and I am connecting it to the positive side of the battery. That is, color code is at red, and the negative side should go to the LED. So let us take it from over here. I'm connecting it to this end. So this actually gives the entire row as negative, right? So this gives the entire row as negative, and let us pull the negative from here. So this actually makes the connection incomplete. Okay. So we have another terminal one of the LED of the switch remaining, and the LED or the register should be connected. So let us connect these two terminals again. So now my circuit is a complete circuit. So how to check it? Just go to start simulation. Whenever you see the slide switch is on the left hand side to the LED, or you can say it's connecting the common and the terminal one, the LED is glowing. Whenever I slide the switch, the LED turns off. So this actually says the switch, we are using the switching mechanism. Or you can say we are closing and breaking the circuit with the help of a switch. All right. So let us explore another terminal of a switch, right? This is another terminal. So similarly, we'll be connecting another LED to it. So whenever, as we connect the LED, let change the color of the LED to, say, example, green, right? Now, I always tell you people, like whenever you are connecting a LED, never ever forget to connect a register. So our next principle is to connect a register. So take a register and connect it, right? Now I have this negative side. Negative side should go to the negative side of the battery. So I have this negative side ready, like internally connected in the breadboard, connecting the negative side of the LED to the battery itself. And again, the positive side, or you can say the side which has a register, should go to the terminal 2 of our switch, like this. So let us color code it. Okay, this make the circuit complete for both the red LED and the green LED. And let's start the simulation. Now see, if the switch is on the left hand side, the red LED is glowing. Now if I slide the switch to the right hand side, the green LED is glowing. That means whenever I slide the switch, a portion of the portion of the switch is making an open connection, and the portion of the switch are making a closed connection. So when the switch is slided to the left, the connection between the red LED and the battery is broken. When I shift the switch to the left, the portion of the connection between the green LED and the battery is broken. So this is how we can work with the switch, or you can play around with this slide switch in a like in your according to your requirements. Okay. So let's stop the connection. Right. So let us clear our window for a bit. Okay. So our next principle will be exploring another type of switch, which is called a push button, right? So this is a push button you will be having. So there are four terminals: 1B, 2B, 1A, and 2A. So whenever you are connecting a push button, always remember you should connect with the alternative terminals. If you are connecting a negative end to a 1B, always try to take a uh, output from 2A also, right? So the connection should be in the opposite direction, right? So I show you two people, like why I'm telling this. Like let's take a LED, And again, let's take a battery for our power source. And whenever we have a LED, we always have a register. So there goes a register, right? Now the negative end of the LED is connected to the negative side of the battery, and the positive goes to the the positive one goes to the switch, and from the switch we connect to the battery, right? Okay. Now let us check what happens when you do on start simulation. This is start simulation. The working mechanism of the push button is whenever we switch on the button or whenever we click on the button, the LED should glow or the circuit should complete. Let us check. Right. See, I'm clicking the button, my LED is glowing. Right. So I tell you people like use the alternative terminals. For example, now if I go and change the terminal to this, okay, and go to start simulation, it is always on for a bit. Like it is always on. We can't make it stop because the connection is complete by default. That's why I requested you people to go to the alternative terminal. If you're connecting to 1B, another terminal should be your 2A. Or if you're connecting to 2B, another terminal should be your 1A. Accordingly, the switch works. Like sorry, the push button works. So this is our correct connection. When you go to start simulation, by default, the circuit is broken. Whenever we click on the switch, the circuit is closed, or you can see the LED is turning on, right? So that was the example of another component called push switch, or you can say the push button. Okay, right. So from here, let us dive into a basics of our electrical components or electrical circuits, and let us study how series and parallels work, right? So series means when positive is connected to negative, or you can say when both the terminals are connected to, like if you see a register, right? Registers are defined by this in our electrical circuits or your electronic circuits. So series connection will be like this, when this connected to this and another register connected to this, right? This is our series connection, and you have to take output from here, right? In the series connection of a register, what happens, like if there is a 1 kilo ohm register, this is a 1 kilo ohm register, and this is a 1 kilo ohm register, we get a equivalent resistance. We get a equivalent resistance of 3 ohms, like 1 plus 1 plus 1, right? So for example, if this is A, this is B, and this is C, our equivalent resistance in series R will be A plus B plus C, right? Okay. And next, let us discuss how our equivalent resistance will be in parallel. So for example, this will be my parallel connection, right? Okay, this will be my parallel connection. If this is as A, B, and C, okay, and this is my output, my equivalent resistance will be 1 by R equals to 1 by A plus 1 by B plus 1 by C, right? So accordingly, you can calculate and like change that. You can say make it 1 by R to R. So accordingly, from the mathematical calculations, you can calculate the equivalent resistance in parallel. So this is how we calculate the resistance when it is connected in series and the resistance when it is connected in parallel. So let us take a practical example of it. For example, if this is a register, I want to connect it in series. For that, let us take it as 1 kilo ohm, another register of 1 kilo ohm, right? And another registers of 1 kilo ohm, right? Okay. So this should be my connection look like. These three registers are connected in series. Okay. Now how to check this actually is giving me 3 kilo ohm. Okay. For that we have a component called multimeter, right? Multimeter help us to measure different things. The current flowing through it, or the ampere, the voltage flowing through a circuit called the defined as volts, and the resistance in a circuit called the resistance, or the resistance in a circuit, the resistance, or you can say the how much kilo ohm or the ohm the resistance is. right? We use a multimeter over here. So how to check it? Like if I take a single register like this and connect its terminal, one to the negative of the multimeter, one to the positive of the multimeter. And I go to start simulation. Okay, for that, I have to change this mode from voltage to resistance. You have three modes, one for the amperage for the current, one for the voltage, ampere for the current, one for the voltage, and one for the resistance. Let us now go for the resistance. If I go for the resistance and go to start simulation, see, you get 1 kilo ohm. And actually, I have taken a 1 kilo ohm resistor. See, so this actually satisfies my conditions that my what I have taken and what I am getting is actually right. So as I told you, as I told you people, like when I connect registers in series, it actually gives me equivalent resistance of the resistance will get summed. Or you can say this resistors plus this resistors, this resistance plus this resistance, or the plus this resistance. So my equivalent resistance will be of 3 kilo ohm over here. So let us go and check. Let us connect this terminal to the to the negative and this terminal to the negative. Okay. So it's already in resistance and let us start simulate. See, so it's actually giving me 3 kilo ohms. So when you connect resistors in series, the resistance adds up. Okay, right. So similarly, you can check how the connections in parallel also. For example, if this is my 3 resistance and I want to connect it in parallel, my parallel connection should look like this, right? This is my 3 resistance. Let us connect them together. Okay. Now let us take a ohm meter. Now let us take a multimeter and connect it. One end should go to another terminal and another end should go to the terminal 2. So this completes my connection, right? And now for our satisfactory, let us change it to one is my 1 kilo ohm resistance, another let it be my 2 kilo ohm resistance, and for example, another one let it be my 3 kilo ohm resistance, right? So this actually completes my connection, and let us go to resistance and start simulation. See, it's actually giving me 545. So when you calculate it, you will be seeing that 1 by 3 plus 1 by 2 plus 1 is actually, or when you calculate it, it will actually give you like 0.54 something. So that means your calculations or your theoretical knowledge and the practical knowledge are both the same, right? So this actually satisfies your parallel and the series connections of the resistors. Okay. Similarly, if you look into the kinds of the LEDs or the bulbs, you can even connect LEDs and bulbs in series and parallels also. For example, if I pull up the breadboard again and I take three LEDs like this is my first LED, this is my second LED, and this is my third LED, right? Let us connect them. This anode is going to cathode, and again, this anode is going to cathode, right? So let us take a resistor to protect our LEDs. This resistor is going to the anode, and from there we take a battery. Take a battery. This is my positive terminal or the anode. This terminal should go to the positive side of the battery or the 9-volt battery. Sorry, this of the 9-volt battery, and the negative side should go to the negative side of the another LED or the cathode, right? So let us color code it with black. So this actually completes my circuit, right? So when I go to start simulation, see all the LEDs are glowing in series, right? So since it's the simulation, you can't find the actual difference between the intensity of the LEDs. Okay, so if you try it at home, you will see the first LED will be at the brightest stage. Next should be a little dimmer, and the third one will be in dim at like it will be in the lowest brightness, right? So in as you say in series, the current gets divided. right? The current is getting divided like this. Now again, so this is the condition of the series connection of the LEDs. Next, if we move on to the parallel, right? So let us move on to the parallel connection of the LEDs. This is my 3 LED, right? Okay. So let us take 3 resistance to protect our LEDs. Okay, there's a 3 resistance. Now let us connect the LEDs in the series section. Series means all the same terminals should be connected to the same terminals, right? So this side, I'm connecting it to the negative end again. Anybody saying anything? Okay, sorry. So again, this terminal, the cathode should go to the negative side, and this cathode will also go to the negative side. Right. So the connection of my cathode is done. Now let us connect the anode. So let us take it from the positive side. Let's color code it as red. Go to the positive side and go to the positive side, right? And now let us take a battery. The positive has been connected to the positive side, and the negative has been connected to the negative side, right? Let's make the circuit complete and let us go for start simulation. Okay. So this also says my connection is correct and the LEDs are connected in parallel this time. So in parallels, you will see all the LEDs will be having the same intensity. So it is very difficult to distinguish in online platform, in the simulation platform. But whenever you are doing it the hardware, you can always go for the difference. Okay. So this was your part of like how to connect your LEDs in series and parallels. Okay, fine. Now let us check what happens when we connect two batteries or two or more batteries in series or parallels, right? So that is also our experiment, right? We have seen resistance connected in series gets adds up, right? And the resistance connected in parallels, automatically the resistance has been divided. Now when you see in like the LEDs are connected in series, the current is divided and the intensity is being different, and in parallels the intensity is same. So there should be something when we connect the batteries or the power sources in series and parallels. Okay, let us explore this time. So this is our battery, right? This is our battery. Let us take a 3 different batteries. Okay, so this is our three batteries of the same element, and let us connect it in series. So a very good example of a series connection is your remote. Like this remote, one is upside down. This actually explains that two batteries are connected in series. So for that, let us try and connect our batteries in series. In series, the one goes to the negative, and again the positive one goes to the negative, right? And you have this positive side and we have this negative side. So let us take the multimeter out of here and let us try to connect our one to the positive end and one to the negative end, right? Like this. So what do you think the equivalent voltage will be, right? Let's go and check. So if I go to start simulation, my equivalent voltage is 27. So how 27? It's nothing. 9 plus 9 plus 9, right? 9 plus 9, 18. 18 plus 9 is 27. So actually when power sources or you can say the batteries are connected in series, the voltage adds up. The voltage adds up and it gives you a equivalent voltage of like R or you can say V plus V plus V or the 3V, right? So you will be like having a doubt what if like so Avik, you are connecting positive to the positive and negative to the negative. What if we connect in the other way to the multimeter? No worries. Like if you have a doubt, go and experiment. This is where the platform is. Like ThinkerCAD is all for your experimentation. So I'm connecting. Let us connect this one is positive. So let us go and connect it to the negative, and this one is negative. Let us go and connect to the positive, right? So if this was the case, and I go to start simulation, I get a equivalent voltage of 27, but this time a minus sign in between. That is because our current is flowing in a reverse direction, and the multimeter catches it. That's why, like in a DC current, our polarity is always taken care. So if we don't take care about the polarity or the positive and the negative terminals, we could get a different errors. Like we are expecting a value of 27. Now we are getting a value of minus 27, right? So this is the key. Is like any doubt you have, like don't wait for the next class, or you can go and ask in the WhatsApp group, or ping any of us like who are giving me or sort of sir, any of us. But at the meantime, if you're facing any doubt, or if you're facing any difficulties, like go and experiment in the Thinkercad itself. Like if you think what happened if we connect the LEDs directly to the battery, what happens if we connect a buzzer to the battery. Like go and experiment. This is the Thinkercad is all about experimentation, because this is where we start building our system, and you can say start building our circuit, so that no mishap occurs in the like hardware part itself, right? So we explored how to connect our batteries in series, right? Now let us explore how to connect in parallel. In parallel, you will be expecting like all the terminals should be connected with the same terminal, right? For example, series in series, like negative to negative and positive to positive, right? If this is our this is our battery, right? Let us connect it. The negative side should go to one to negative side, another to the negative, and this to the negative. Similarly, let us take the positive one over here, right? And another positive one, and here the another positive one. So we are getting a connection like this, right? Okay. So we are getting a connection like this. So let us take the multimeter again and check what will be our equivalent voltage, right? So if I again connect the negative side to the negative and positive side to the positive like this, okay, right? So if I go and check, I'll get a equivalent voltage of 9 volt. Okay. This is why, because when power sources are connected in parallel, I gave a equivalent voltage of the higher potential only. Like this time, if my equivalent voltage, like the voltage are same, so I'm getting a voltage of 9 volt only. This happens when we connect power sources in parallel, right? So you will be thinking like a connection is bit messy. Yes, parallel connections are a bit messy. So if you don't have to like worry about it, breadboards takes all the care. If you are trying to do without the breadboard, like you have to take the multimeter, again connect the positive individually like this. Take the positive side to the positive, okay, and take the negative side to the negative. Negative side to the negative, and again negative side to the negative. Again, if we start the connection, you will see I am getting a similar voltage of 9 volt. So this actually satisfies my series connections of the power sources and series connections and the parallel connection in the power sources. So till now, like let us summarize, like we have learned how to work with the LEDs, how to protect our LEDs, and how to connect the LEDs in series and parallels. Next, we have learned how to connect our registers in series and parallels. Now we have learned how to connect our power sources or batteries in series and parallels. Right. So this actually completes the basic electronics components. Okay, one more thing I am missing out, like this is the motor. Okay, the main mechanism of a motor, DC motor, is it converts the electrical energy to mechanical energy. Like when the motor rotates is a form of mechanical energy, right? So in the form of mechanical energy, you can like it's converting the electrical energy to mechanical energy. How to check it? So let's take a battery over here, right? Let us connect the motor terminal, the positive one to the positive and the negative one to the negative. Actually, motor doesn't have a positive and the negative terminal. So according to it, you are connecting the motor rotation. The direction of the motor will keep on will go like this. For example, if I am making a connection like this, sorry, okay, red one to the red and the black one to the black. And if I go and start the simulation, you will see the motor is rotating in the clockwise direction, right? And with a RPM of 17568, right? This shows the motor is rotating at the clockwise direction with a RPM of 17568. So if I stop the connection, stop the simulation and alter its terminals. For example, let us connect the red to black and the and vice versa, and similar to the other side also, right? Okay. So uh, if I go and check the start simulation, you will see the motor is rotating at a counterclockwise, okay, with the RPM of minus 17568. So actually, with the polarity of the battery, you can actually change the direction of the rotation of the motor. It can go for clockwise or it can go to anti-clockwise according to the polarity of the of its power sources. Right. So one more thing I will like put your put your importance on it, like a potentiometer, right? So this is a potentiometer. Potentiometer is nothing. It's a variable resistance. For example, the common example is your regulators, fan regulators. What fan regulators do? It actually varies the potential, but actually varies the resistance. When you increase the resistance, the fan speed decreases, and when you reduce the resistance, the fan speed increases. Right. So let us have a good understanding of the resistance or the potentiometer or the variable resistance in this simulating platform. Like I have this two terminal, terminal one and terminal two, and I have three terminals, terminal one, wiper, and terminal two. Let us connect it. Just a second. Okay. So okay, let us color code it for you people. Just turn it red and let us turn it red. Okay, so this actually completes the connection. One is from the wiper section of the middle terminal, I'm connecting to the battery, and from the terminal one itself, I'm connecting to the motor. And other side of the motor is connected to the another side of the battery, right? So if I start the connection, see my resistance is low over here, right? My resistance is low, so the motor speed is very large, 1742432. Whenever I increase the resistance, my motor speed actually keep on decreasing. See, it actually keep on decreasing and finally it stops, right? It's about doesn't stop, but rotates at a very slow rate, like 5 RPM. Again, when I reduces the resistance of the potentiometer, its speeds actually gradually increases. So this is the example you can say how motors are connected with the potentiometer, or you can say in the practical examples in your real life, you will see how fans or your fans regulators are connected in your real life. We use a variable resistance, or you can say we use a potentiometer over here. So as we keep on increasing the resistance, it's like the speed of the fan decreases, right? So this actually makes a end of the basic electronic circuits of your the sections. Okay. From now onwards, I believe we'll be starting a microcontroller, the its name as Arduino, right? So I'll give a basic introductions of Arduino today. and we'll show a very simple simple circuit. And from the next class onwards, we'll be doing a good hands-on on Arduinos, right? So this is a Arduino. So if I go and check, this is a Arduino, and it name says as Arduino Uno, right? So what is the purpose of Arduino? Like we have this electrical circuits. Now, why does we certainly need Arduino? Like Arduino has a intricated chip. You can say it's a microcontroller which has an intricated chip inside it, which actually allows us to program our electrical devices, even electronics devices, according to our needs. Like if you want to control the fans, or you can see if you want to control the lights of our house with the with our coding, like for example, street lights. What happens? Like whenever there is darkness, the lights automatically glows on. It's like there we are using Arduinos. Like this Arduinos take the data from the sensors. There's a sensors called LDR sensor. Like this is say photoregisters. These are called photoregisters or LDR sensors. So when there is a increase in darkness, the resistance goes high. Accordingly, we program our Arduino that when the resistance is high, we need to turn on the LEDs, right? Or you can say we need to turn on the lights. Whenever the resistance is low, we don't need to turn on the lights. So according to the logic, we fit the Arduino, and we do the coding itself, right? So here in the Arduino itself, we'll be needing coding, we'll be needing the circuitry knowledge, and many more things when you're exploring Arduino in your real life also. Right. So this is a very you can say a good example of Arduinos. You will be getting a few listed of components, not all, but few components over here so that you can start. But always recommended if you're working with Arduino, it is always recommended to like do it in the uh, practical itself, or you can say in the real hardware itself, because that's how we actually gain knowledges. Okay, so whenever, so this latest our first project will be how to connect a LED with the Arduino, right? So let us take the breadboard. So we will be always be needing a breadboard. Okay, we'll be always be help need the help of the breadboard to connect our different circuits. So let's take a LED. As I told you people, LED. So as I told you people, like LED is always encountered by a register. So let's take a register over here. So this actually completes my circuit. So now you will see there is an option. Uh, Anybody? Okay. So you will be seeing that we have a pin called ground. Okay, ground is nothing but the negative side of our terminal. So whenever the negative side of our anything is always been connected to the ground of the Arduino. So if I take the ground, now I have to complete the circuit with the negative side of the LED, right? So now again, you'll be getting a 5-volt supply from the Arduino, right? This 5-volt supply, and let us take this 5-volt supply and connect it with to the register, right? So actually, this completes our circuit. So if I go and change the color code and start simulation, it will first initialize. Now you see the LED is glowing, right? Now this is not our principle, right? We can always turn on the LED from the battery itself, but let us control the LED with the help of the code, right? So for that, let us take any digital pins. These are all your digital pins from 0 to 30, right? These are all your digital pins. Let us take any of the digital pins. Let us connect our LED. For example, let us connect the LED to 11, E11, and let us try to code it accordingly, right? So according to our need, the LED will turn on or the LED will turn off. For example, let's go to the code section. For coding, you need to go to this section, code. From here, on start, um, let on start, our LED should be on. You can say there's a block code. Okay, so on start, our LED doesn't have to do anything. Now, like this is a forever code. You can say the code in this section, the code will run in a loop, right? So once the loop is completed, again it will go back to the first stage, and again it will complete the cycle, right? So let us set the LED to high. So high here means the LED is set to on. For example, this Arduino understand binary languages, zeros and ones. We know zero means low, right? And one means high. That basically means zero means off and on means on. So this actually this logic has to be remembered by us when you are coding with Arduino. For example, if you're saying that the Arduino that the LED should go to set built-in LED, or you can say, okay, let us take the set pins and to okay, let us try with the built-in LED. Okay, Arduino has a built-in LED called L. Uh, so what we'll be doing, what here we'll be working with this built-in LED. For the built-in LED will be high, and after a wait of 1 second, the LED should go to low, right? So if we go to start simulation, it will initialize, and if you go on to this section, you will see the LED is actually blinking. Right. So the LED is actually blinking over here. So now our main task is to how to control this LED with this Arduino, right? So let us go to code. Right. Let us go to code over here. There's a void setup section. This setup section is actually tells you how to set things up for the Arduino, right? You have to set a pin number. We are using 11 over here. And the type of device, LED, in terms of LED, it is an output device. Definitely it's output device. Okay. So in the loop itself, we are saying that digital write, or you can say you want to send some signals to the LED. That's why you are using the command called digital write. And now from the digital write, the pin, again the pin number here, the 11, or you can say the pins which are connected to the pin number 11 should go to high. Then again we are giving a delay, right? We're giving a delay of 1,000, or you can say the 1,000 milliseconds, because Arduino understands language in milliseconds, so the time in milliseconds. So 1,000 means 1,000 milliseconds. Now again we are sending a signal to the Arduino about the to the LED about that we need to digital write the LED as low, or you were turning off the LED, right? And again we are giving a delay of 1,000. So this actually tells us how we are turning on the LED for a certain interval of time and turning off the LED for a certain interval of time. So in our practical knowledge, it will show that the LED will blink. It will blink for, like, it will go on for 100 milliseconds. Again, it will turn off for 100 milliseconds. Again, since this is in a loop, again it will go on for 1,000 milliseconds, and again it will turn off for 1,000 milliseconds. So this is our actual purpose. So let us start the simulation. When you start the simulation, see, if we check on the LED very carefully, it is glowing, like it is giving a blink, right? Blinking with a wait of 1,000 milliseconds. So that was our main motive, how to achieve, you can say, how to achieve coding, or you can say the how to control the basic electronics devices with the help of Arduino. Like accordingly, we have different sensors. Like we have RGB LED, we have motors, we have ultrasonic sensors, we have PIR sensors, we have buzzers. So accordingly, in the upcoming sections, also in the upcoming classes, we'll be trying to cover each and every like elements, you can say, each and every components, and we'll be interfacing with the Arduino, and we'll check how we can connect the Arduino and how we can control the devices. And from controlling the devices, we can again how to take the input, how to give the output. There are different pins called digital pins, and in some cases we'll be going to use the analog pins also. So accordingly, we'll be doing it, and again, and this journey will be really be great when it comes in the forward direction, because there is never ending, like this experiments will go on. You'll be having some ideas, and other people will having some ideas. We'll be collaborating these ideas to a different intervals. Okay. So like, and making the circuits completely, making the projects complete. So I believe you'll find a great interest in this. Okay. So with this tone, like I will like this actually finishes the content of today's class. We have a small window open. Like you can, if there is any doubt from anyone, you can surely come up. like if you're facing any doubt, you can either post us in the chat box itself or can unmute yourself and can see us. Okay, up to you, people. Any doubt, like and this and exceed, we never say a doubt is a silly or a doubt is a very small. Every doubt is important to us because it may be like small to you, like small to you, but it's never small to us because we are here to cater your doubts. We're here to like if you're facing any problems, we're here to solve it. Okay, anybody, anyone facing any difficulties here? Okay, with this, I think we are good to go. Like, since no more doubts are coming on, and everybody is have taken the class and have understood what we have gone through. We have covered basic electronics components, and with this final summary, I will like wind this class up. With that, we have learned how to do the connections in breadboard. We have learned how the breadboards are interconnected. Next, we have learned how like registers are important for us. Sure, ma'am, sure. Uh, it's very okay. Like if you have to try yourself, again, when you're trying it yourself, if you're facing any difficulties in between, go and come up with your difficulties in your group itself. Okay, we'll be ready to solve it out. And okay, so I was telling the summary. Okay, so that was we have learned how to connect the breadboard. Next, we have connect how to tried how to connect the LEDs in series and parallels, and you have checked how to connect the registers in series and parallels. Next, we have checked how to connect the power sources or the batteries in series and parallels. Next, you have learned how the use of multimeters, and then you have learned how motors are connected and the polarities of motors and how motors and our fans regulators are practically implemented. We have used a device called potentiometer again. And next, I have give you a basic introductions of Arduino, right? So that was all about today's class. Okay, so since anybody we don't have a doubt right now, I will expect you people to try it out by yourself. And if there is any difficulty, do reach out to us at any point of the time. So with this note, thank you everybody. Thank you everybody for joining. Thank you for uh, listening to me and taking your time out and joining this session. Okay. Thank you everybody. Thank you. Have a nice day ahead.